students, today's lesson is on the product of powers property. So we'll start by defining some properties. The first is the product of powers property, and that tells us that to multiply powers with the same base, we'll add their exponents. So here if we have 4 squared times 4 to the third power, both of those powers have a base of 4, so we can just add their exponents. We can look quickly at why that's true. 4 squared is 4 times 4, and 4 cubed is 4 times 4 times 4. So if we look at that all together, we have 4 multiplied by itself 5 times, or 4 to the 5th power. The second property is the power of a power property. This tells us that to find the power of a power, we'll multiply the exponents. So here's what that looks like. If we have 4 to the 6th power, that's a power, and then we have this power in parentheses taken to the third power. So we're taking 4 to the 6th and multiplying by itself 3 times. And when that's true, we can multiply the exponents. So let's look at why that's true. Here's what 4 to the 6th looks like. 1, 2, 3, 4, 5, 6. And if we multiply that by itself 3 times, we have to write this whole expanded form 2 more times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we can see that when we write this out in expanded form, we actually have 18 total 4s. So we can do that by just taking the 6 and 3, the 2 powers, and multiplying them. Last is the power of a product property. So this says to find the power of a product, find the power of each factor and multiply. So here if we have the base itself is a product and we're taking that product to a power, we can find the power of each of those factors and multiply. So 3 times 2 to the 5th power in expanded form would look like this. 3 times 2, 3 times 2, 3 times 2, 3 times 2, 3 times 2. And if we reorganize these using the commutative property, we have 3 multiplied by itself 5 times and 2 multiplied by itself 5 times. Now, because these, the products within the base of this example are both numbers, you would get the same result if you multiplied 3 times 2 is 6 and took that to the 5th power. You would get the same result. But sometimes you can't simplify the base because one or both of the one or both of the factors are exponents. Okay, so let's go ahead and do an example multiplying powers with the same base. I'm going to write the first one out in expanded form. So here we have 2 to the 4th, 1, 2, 3, 4, times 2 to the 5th, 1, 2, 3, 4, 5. And altogether, that's 9 2s, so that's 2 to the 9th power. Now, because we know this property, we don't need to always write it in expanded form. I'm just showing you that so that we can understand why it works. For our second example, we have -5 times -5 to the 6th power. So that's -5 times -5, -5, -5, -5, -5, right? In total, we have 7 -5s, 1 here and 6 more here. So that's -5 to the 7th power. And our last example, x to the 3rd times x to the 7th. In total, that's x to the 10th power. All right, next example, let's do the power of a power property. So here we have 3 to the 4th power and that whole power taken to the 3rd power. So let's write this one out in expanded form. We have 3 to the 4th, that's 3 to the 4th, and then we're going to take that whole thing to the 3rd power. So in total, we have 12 3s, or 3 to the 12th power. Okay, let's do this next one without writing it out in expanded form. We have w to the 5th, that whole power taken to the 4th power. So we're going to multiply 5 times 4 to get w to the 20th power. All right, example 3, we're doing power, finding the power of a product. So here we have 2x to the third power. So in expanded form, it would be 2x times 2x times 2x. I can rewrite that as 2 times 2 times 2 times x times x times x, or 2 to the third power, x to the third power. We'll do the next one without writing it out in expanded form. We'll just say 3xy, that whole base squared, is going to be 3 squared times x squared times y squared. And then we'll simplify this. 3 squared is 9. When we write this in simplest form, we don't need those multiplication symbols. We could just write 9x squared, y squared. All right, last example. A gigabyte of storage on a computer is the same thing as 2 to the 30th power bytes. The details of a computer are shown. We want to know how many bytes of total storage space the computer has. So we see that the total space is 64 gigabytes. So let's start with that. And let's write that 64 as a power of 2. So that would be 2 to the 6th power. 2 times 2 times 2 times 2 times 2 times 2. So that's how many gigabytes of storage we have. But we know that each gigabyte is the same thing as 2 to the 30th bytes. So we take our 2 to the 6th and we're going to multiply by 2 to the 30th. So that's 2 to the 36th power bytes. All right, that's it. Go ahead and try a few on your own. I'll see you soon.